Good day everyone, you are welcome back to class. Today we are going to be studying matrices. Now let's begin to look at what a matrix is all about. Now a matrix is a rectangular arrangement of numbers, symbols or objects in rows and columns. So we are going to take a look at some examples under this so that you will understand what matrices are all about. Now the first example we are going to be looking at is 2, 3, 4 and 5. Okay, so this is an example of matrix. You can see that it is arranged in a rectangular way, and the name of this matrix is called 2 by 2 matrix. And why do I call it a 2 by 2 matrix? It is because this matrix is having 2 rows and 2 columns. Don't worry, when we get to order of matrices, I'm going to tell you more about rows and columns. But let me give you another example here. We also have 2, 3 and 4. So this is another example of a matrix. And this matrix now we have 3 by 1 matrix. So we are meaning that we are having 3 rows and then 1 column. Then another example is 4, 5, 8. So here we are having just 1 column and then 3 rows, 1 by 3 matrix. Then we also have this as an example of matrix 2, 0, 4, 1, 3, 3. So here we are having 3 rows and then 2 column. So this is a 3 by 2 matrix. Now finally we also have this type of example of matrix 4, 5, 6, 7, 8, 9, 1, 2 and 3. Okay, so here we have 3 rows and 3 columns. So this is a 3 by 3 matrix. Alright, so these are the example of matrices. You can see they are all arranged in a rectangular form, both either horizontally or vertically, as you can see. Now let's continue. We are going to now take a look at order of a matrix. Okay, so let's assume we have a matrix called A. Well, let me tell you at this point that a matrix is always represented with a capital letter. Okay, capital letters, as you can see this matrix A on the screen. So let's assume A is a matrix and it has this order. We have 1, 2, 3, 4, 5 and 6. Okay, so before I tell you the order, let me quickly show you the rows and the column. All right, so you see this 1, 2, 3 on the horizontal arrangement as they are is what we call row. So this is our row 1. Okay, so this 4, 5, 6 on the horizontal arrangement is our row 2, like that. Okay, so this 1 and 4 vertically this way is our column 1, the first column. Then this 2 and 5 is the second column, and then 3 and 6 here is the third column. Understood? Okay, now let's write the order of this matrix A. The order will be, how many rows do we have? We have 2 rows. There is going to be 2 by how many column? 3 column. So this is a 2 by 3 matrix. Understand? Well, for you to write the order of a matrix, this is what you follow. Let me just say order, okay, is equal to, you first of all write the row, then by the column. Do you understand that? So this is just the simple trick behind it. Once you can follow this, then you are good to go. And don't forget, I have labeled it for you. The rows, they are the horizontal arrangement of numbers, and then the vertical arrangement of numbers at the column. Is that understood? All right, so we continue to look at the types of matrices. Now let's take a look at the first one. The first one is what we call zero, or you can call it null matrix. Okay, so zero or null matrix. So this is a type of matrix whose entry are all zeros. So all the entries of a null or zero matrices are zero. Let's take an example here. Example. Okay, example. When you have this, yes. So this is an example of a null matrix or zero, where this is a 2 by 2 zero matrix. Okay, so if I give you another example now, 0 0 0 0 0 0 0 0 0. So the order of this zero matrix is a 3 by 3 zero matrix. Understood? So that is what zero or null matrix is all about. Let's take a look at the second type of matrix. Well, we have row matrix. Row matrix. So row matrix is a matrix with only one row, just one row. All right. So example. When you have 4, 5, 8. Okay, so how many rows do we have here? Just one row. All right, so we have one row and then 3 columns. But since we are having one row, so we call it a row matrix. Number 3 is a column matrix. Column matrix, and then this is when you are just having one column. Okay, so for example, you have 4, 5, and 8. So here we are having just one column, though we are having 3 rows, but one column. Since we are having one column, we call it a column matrix. Now let's proceed to another type of matrix, number 4. We also have square matrix. Square matrix. All right, so a square matrix is a matrix whose number of rows equal the number of column. All right, so let me give you an example here. For example, when you have a matrix called M and is given as 4, 5, and 3, 2. Okay, you can see we have 2 rows and 2 columns. So this is a square matrix. Understood? Now let's take a look at the fifth type of matrix, and that is what we call identity matrix. Okay, so identity matrix, it is denoted by I. Understood? So, and this identity matrix is given as 1 0 0 1. You can see that we have 1 arranged in a diagonal way. So when you have something like this, this is an example of an identity matrix. Understood? So but this type of identity matrix is called 2 by 2. So 2 by 2 identity matrix. Well, we have another one. The second example, when we have a 3 by 3 identity matrix and it's given as 1 0 0, then 0 1 0 0 0 1. So this is a 3 by 3 identity matrix. You can see that the 1 is arranged diagonally. Understood? Well, we are going to stop here at the types of matrices. Then let's begin to look at some practical questions under this matrix. So the first questions we are going to be solving is under addition and subtraction of matrices. So how do we add and subtract matrices from each other? let's do that with this first example. Solution. So in this question, we are given A to be equal to 6, 4, 12, and 6. And then B is given as 2, 3, 4, and 5. Then we are told to find A plus B. So firstly, we are looking for A plus B. So now A plus B will be equal to, what is the value of A? So A is 6, 4, 12, and 6. Then plus B, and our B is 2, 3, 4, and 5. Now let's add it together. So this is how to add. You pick this 6, okay, and add it together with this 2. Then next you pick this 4, you add it together with this 3. So that's how we do it. Now let's write 6 plus 2, then leave it, 4 plus 3. Then we pick this 12 also, plus this 4, then this 6 plus this 5. Understood? So let's quickly add that. 12 plus 4, then 6 plus 5. So when you add that together, what do you get? So we have A plus B to be equal to 6 plus 2, that is 8. Then 4 plus 3, that is 7. Then 12 plus 4, that is 16. And 6 plus 5 will give us 11. So this is the value of A plus B. So that's how to carry out addition. Then the Roman figure 2, we are told to find A minus B. So now A minus B is giving us, A is 6, 4, 12, and 6. Then minus B, which is equal to 2, 3, 4, and 5. So alright, we pick this 6 minus this 2, this 4 minus this 3, just like we did the addition. The only thing that is different here is sign. So we have 6 minus 2, then 4 minus 3, then we have 12 minus 4, and 6 minus 5. So let's subtract this from each other. We have 6 minus 2, that will give us 4. 4 minus 3 will give us 1. 12 minus 4 will give us 8. And 6 minus 5 will give us 1. Okay, so this is the solution to the first question. I hope you understand this. Very simple. Well, let's take a look at another question. The question says, if K is given as what you are seeing on the screen and L also as what you can see on the screen, then find a matrix such that 2K plus L plus M is equal to 0. Solution. So we are going to work with this equation given to us, that is 2K plus L plus M is equal to 0. So we have a coefficient here, which is 2 times K, and our K is given to be minus 1, 2, 3, and 4, then plus L, and L is given as 4, 5, 6, and minus 7, plus M equal to 0. So we are going to carry out this scalar multiplication first, that is this 2. You are going to use it to multiply everything inside this bracket one after the other. So 2 times minus 1 will give us minus 2. 2 times 2 is 4. 2 times 3 will give us 6. While 2 times 4 will give us 8. Okay, so now plus 4, 5, 6 minus 7 plus M equals 0. Now let's carry out the addition. Just like we did in the previous question, we'll take this minus 2 plus this 4, then this 4 plus this 5. That's what we are going to do here as well. So I write we have minus 2 plus 4, then 4 plus 5, then we have 6 plus 6, and then 8 plus minus 7. Okay, so put it in bracket, plus m equal to 0. So we continue here. Now minus 2 plus 4 will give us plus 2, 4 plus 5 will give us 9, 6 plus 6 is 12, and then 8 plus minus 7, plus times minus is minus, then we have 8 minus 7, that will give us 1. Okay, so plus m equal to 0. So here let's retain our m at the left hand side. So while we take this matrix to the right hand side, but when we take it to the right hand side, we now have minus, then the whole of this matrix. Understood? So m now is giving us, I'm going to use this minus to multiply everything inside the bracket. Okay, so when I do that, I have minus 2, minus 9, minus 12, minus 1. So, and this is the value of m. Okay, so this is what they asked us to do, and we have successfully done that. Now let's take a look at another question. The question says, if matrices P and Q are what you can see on the screen respectively, find the matrix 2P minus Q. Solution. So we have P first to be 2 minus 1 and 5 and 6. While Q is given to be 10, 5, 3, and then 2. So the question says find 2P minus Q. So 2P minus Q will be equal to our, just write this 2 is a constant, then multiply by P. P is given as 2 minus 1, 5, 6, then minus Q, and Q is 10, 5, 3, and 2. Okay, so multiply this matrix by the 2. So everything inside this bracket, multiply it by 2. 2 times 2 will give us 4. Then 2 times minus 1 will give us minus 2. 2 times 5 is 10. 2 times 6 will give us 12. Then we are going to subtract that. So we have 10, 5, 3, and 2. Okay, so let's continue at this page. Now, what we are going to do now is to subtract. So we are going to say 4 minus 10, then minus 2 minus 5. Okay, that's the rows on top. So we have 4 minus 10, then minus 2 minus 5. Then for the second row here, we have 10 minus 3, then 12 minus 2. Okay, so let's quickly do that. We have 10 minus 3, then 12 minus 2. So put them in bracket, equal to 4 minus 10 will give us minus 6, minus 2 minus 5 is minus 7, then 10 minus 3, that would be 7, and 12 minus 2 will give us 10. Okay, so that is the solution to this question. So let's continue. Yet we have another question here. The question says, given that matrix K is given as this, then find the matrix 2K plus I, where I is the 2 by 2 identity matrix. Solution. So we're given K to be equal to 2, 1, 3, 4. Okay, so here they are saying another thing here. They said I is the 2 by 2 identity matrix. You will remember when we were looking at types of matrices. We talked about identity matrix, and specifically we talked about 2 by 2 identity matrix. So and 2 by 2 identity matrix is given as 1 0 0 1. Okay, and the question says we should find the matrix 2k plus I. So you should know what this is all about now. 2 times k, we have 2, and our k is 2 1 3 4, then plus I, and the I is 2 by 2 identity matrix giving us 1 0 0 1. Okay, so multiply all of this by 2, and we have 2 times 2 4, 2 times 1 2, 2 times 3 6, 2 times 4 is 8, and you add it together with the identity matrix, which is 1 0 0 1. Okay, so let's add this together and see what we get. So as usual, we have 4 plus 1, 2 plus 0, then 6 plus 0, and then 8 plus 1. So when you add this together, we now have therefore 2k plus I is equal to 4 plus 1 is 5, 2 plus 0 is 2, 6 plus 0 6, 8 plus 1 is equal to 9, and then that is the answer to this question. Understood? Finally, let's take a look at this question. The question says, let x be equal to this, y is as given on the screen, and z is as also given on the screen. Then find the values of w, x, y, and z if x is equal to y minus z. Alright, so we have been given the value of x, y, and z, so I will just begin by writing this equation: x is equal to y minus z. Okay, so let's plug in the values of each letters or each matrix is understood. So matrix x is given as w, y, x, z, then equal to matrix y is given as 3 minus 2 1 0, then minus matrix z is given as 6 1 0 minus 4. Okay, so let's keep solving the matrices at the right hand side. So I'm going to repeat this: w, y, x, z is equal to, I'm going to take this 3 minus 6, then minus 2 minus 1 as usual. So let's do that. We have 3 minus 6, then minus 2 minus 1. Then the down rows, we have 1 minus 0, then 0 minus minus 4. Okay, so put everything in brackets this way. So coming here, we have w, y, x, and z, okay, to be equal to 3 minus 6, that is minus 3 minus 2 minus 1 will give us minus 3. 1 minus 0 is 1. 0 minus minus 4, minus times minus will give us plus, then 0 plus 4 will still give you 4. Understood? So when you compare all the elements in these matrices, you will discover that w is equal to minus 3, then y is equal to minus 3, then x is equal to 1, and finally z is equal to 4. So those are the values of w, x, y, and z. So with this, we have come to the end of today's class. If you are yet to subscribe to this YouTube channel, kindly hit the subscription button now, like this video and share so that it can reach others. Thank you for watching. Bye.